like pasta.
Hey, is St. Patrick's Day always on the 17th? Okay. That it never moves. It's one of those never moving holidays. Like Easter moves and Christmas doesn't move.
It's Eastern things.
Easter moves.
Easter.
Right. Like Easter's married to a Sunday and Thanksgiving's married to a Thursday, right? But St. Patrick's Day gives no hoots, right? 17th? Okay. This will be the last thing you learn before your next quiz. Your next quiz will have some graphing parabolas in standard form, graphing parabolas in vertex form, and then some algebra part where you don't have to graph anything. You just have to take some standard form quadratics and convert them into vertex form. So we'll work today on this, and then tomorrow should be a good practice quiz day, and then I'm guessing quiz by Thursday. So next quiz coming right up. So the idea here is that we want to be able to take the equations that are in this form, which we know how to work with that, but we would rather not, all things considered, and convert them into this form. So if that looks confusing, that's always the part of a math lecture that you could technically kind of ignore because it's the general equations with the where the numbers would be pulled out and replaced with letters. So that's always, in my history, at least been the part of math that's been the most confusing to me. So if that confuses you, don't worry, you won't be confused here in a little bit. So we're going to take equations like this. And we're going to convert it into vertex form. And you did an assignment on probably Thursday. I think it was Thursday, where I gave you a worksheet full of quadratic equations that were in the nice form, the one with the parentheses, where it's super easy to find the vertex, and then you just have to make the graph. So we're going to make them all look like that. And we're not going to graph anything today unless you really want to, but today's lesson is not about making graphs. We've kind of crossed that bridge already. So today's lesson is just a bunch of algebra. So let's get to it. So there are steps, just like with anything else that I teach you. Generally, there are going to be step one, do this, step two, do this. So that's the same for a lesson like this. So the first thing we're going to do is we're going to rewrite the equation like this. And we're going to scoot the plus 14 off to the side. There's another way to do this without scooting the 14, but over the years, I've just decided that I get more success from my students if we just clear the pathway. So what we're going to do, our goal, remember, is this. We want it to look like this. And so we're thinking that right here, we would love to have something that looks like this. And so, of course, we have to use a skill that we have called completing the square. It comes back again, completing the square. So if you ignore the 14 and just look at the part I've underlined in red, do you know what the magic number is to complete the square? It is a 9. And remember the algorithm in case you're a little bit rusty. We take half of the -6 or the -6, call it whatever you like. Half of that is -3 or -3. And then we square that and we get +9, right? So we are going to add 9 to complete the square. In mathematics, what we've always done up to this point in our careers is we've always said, well, if I add 9 to one side, I have to add 9 also to the other side. Well, here's the problem. Don't write this down. If you do this, then technically you've added 18 to one side of the equation and you've ruined the whole thing. And another consideration is this: if you go to the other side of the equal sign and you add 9 like this, now you've ruined the equation in a different way in that it's no longer y equals. So we don't want to do either of those things that we've grown accustomed to doing. And that's always been since like seventh grade, honestly, it's always been if you add 9 to one side, add it to the other side. But that doesn't apply here. What we actually want to do is take this plus 9 and make it like it was never here. And the way we do that is we subtract 9, which seems really strange to do two things that like seemingly have no purpose. The plus 9, though, has the purpose of completing the square. And the minus 9 is the footprint eraser. That's the number that walks in and says, if you stick me here at the end of this problem, then I can cancel out that plus 9 you put in, and it's like we were never here. So you do something, but then you erase it by doing the opposite of it. And then we're going to take the part that's underlined in red, and we're going to factor it. What does that factor down into? Nice, x minus 3 squared. Good, we've done that. You did a whole assignment on just completing the square. So we know how that factors down. And then over here, all you got to do is some little, like, I don't know, like what is that, third or fourth grade math? What's 14 minus 9? And there is your vertex form done. Don't worry, there's lots of examples to come. But that's it. We just converted a standard form quadratic into vertex form. And listen, if you surveyed 100 people who knew anything about math and said, would you prefer to graph the green one or the white one? Like literally everybody who knows what they're doing would say, I'll take the white one, please, because the vertex is really easy to find. It's obviously at right 3, up 5, and then you just graph it from there. So that's the target. The goal here is to take equations that we don't necessarily like and make them look like ones that we do like. So there you go. There's your first one that generally will get you a little bit lost. And then the goal for the next 10 minutes is to get you unlost. And these will get just progressively a little bit more difficult, except for this one. I tried to give 2 in my note card of every sort of difficulty level, if you will. So here's another easy one. So let's see if you memorized the steps yet. What's step 1? Move the minus 10. All right, so create a landing space. So we're going to leave it as y equals x squared plus 2x. We're going to create a little void, and we're going to scoot the minus 10 an inch or so off to the right. And again, what happens is this part right here that I'm underlining is where we complete the square. And what will be the number that completes the square? Plus 1. And again, if you've forgotten the algorithm, that's because half of 2 is 1 and 1 squared is 1. And how do we erase the footprints of a plus 1? With a minus 1. And just like that, we're home free. So our answer is y equals something squared. What is the something? X plus 1 squared. And then minus 10 minus 1. Just like that. Presto, you've got vertex form. So those are the only 2 examples in the notes today that don't have a number in front of x squared. I think that process should be pretty straightforward. If it's not right now, I don't really want to do like 2 or 3 more at this level. Just let me know a little bit later when it comes work time, and I'll sit down and do a couple with you, okay? But for now, that's the warm-up-y sort of idea. Is it's just simple. You bump the constant, complete the square, factor it down. Should be pretty straightforward. Okay, so now I'm going to start messing with you a little bit. Got it? Step 1 does not change. What is step 1? Move the 35. So we're not doing any math at this point in time. We're just clearing a little bit of a space. So we're going to clear an opening and then scoot the plus 35 off to the right. Good, good. All right. And so now there's a new step. This is not the same as the last problem. You'll notice this time that there's an intruder. Of course, you caught on to this, that there's a number in front of x squared. The whole rest of the lesson revolves around dealing with that number. So what we want to do is we want to get that number out so that when we go to complete the square, it's not there. So we're going to take and we're going to pull a GCF out of only the first two terms like this. So notice I did not try to pull the two out of the back. Don't worry about the back number. The back number is just going to sit there and wait for a minute or so while we do whatever it is we need to do. But we want to divide the first two terms by whatever we have to get the x squared by itself. And then at this point, you're just kind of for 10 seconds or 15 seconds, you're going to ignore the two that you pulled out in front. What's going to be the magic number that completes the square? What magic number am I going to put in this blank right here? Correct. So that's going to be a plus 16. And how do we erase the footprints of that plus 16? Exactly, with a minus 32.
Oh,
Yep. And almost no one in the history of my teaching career has ever jumped to that conclusion without my uh, prompting. But I want to point to a number right here, and I'm going to ask you what it is. And I am not having like a Monday morning stroke. What is that number?
32.
That number is a 32. And you might say it's not. It's clearly a 16. Like I know I've known numbers since I was like little, and I know that that's a 16. But at the end of the day, the fact is this, that is not a 16. That is a 2 times 16. When you pull the 2 out, everything you do inside the parentheses is being magnified or affected by that too. So when we, quote unquote, added 16, if you consider the 2, which you have to, you didn't actually net result add 16 to the right side of the equal sign. You added 2 times 16, which is 32. And the way you offset it or erase its footprints is by subtracting 32. So it's not the number that we think it is. The moment you pull a number off the front terms, everything you do is not quite what it seems. And then from here, we're done. Now we just have to factor. So we're going to have y equals 2 times something squared. What's the something going to be? X minus 4. Good. We're still factoring at that point in time. Okay. Our worry about the 2 is gone. It's subsided. We already took it into consideration when messing with the red number. And then, as always, you can't escape little kitty math at the back of the problem. What's 35 minus 32? 3. And there is your vertex point. Okay. Let's practice that skill one more time, and then we're going to do 2 more things to up the difficulty level. One of them is a negative, and one of them is a fraction. So this will be example 4, and it'll be just like the one you just did. Okay. Steps, steps, steps. I'm a big believer in steps. So what do we do first? Move the 2. And eventually you can start combining some of your steps. Like at that point, if you're already comfortable with the lesson, you would be inclined at that point to have already pulled out the 3. But we're not going to rush it at this point. So having said that, next step is GCF. And remember, we don't GCF the entire polynomial on the right-hand side. We don't worry about the 2. The 2 is in a little bit of a timeout right now. So we're going to divide the first 2 terms, this one and this one, both by 3. Just essentially GCFing it, factoring it out. So we have y equals 3 times x squared. And what goes after the x squared? Plus 4x. And then you keep that space and then leave the plus 2, just kicking it over there. And then the algorithm kicks in. What's going to be the magic number that goes on the blank? plus 4. Half of 4 is 2. 2 squared is 4. So I'm going to add 4. And how do I erase the footprints of that plus 4? With a minus 12. And I mean, you walked right down that road the first time, but now you're wise. I saw a lot of heads kind of shoot up on that last one when I said that weird number, but you're wise to me now. You understand that the number that we add there isn't really what it seems to be. It's being affected by the 3 that we pulled out. It's not really a 4, it's a 12. 3 times 4. And then from here, you should be good to go and factor it out. So we're going to get y equals 3 times something squared. And what's the something in this case? What's inside these parentheses? X plus 2. And then at the back, the little kitty math, what's 2 minus 12? Minus 10 all day. Perfect. Any questions on that? Okay. I have one of this next sort of flavor, if you will, because the last couple of examples, one of them will also cross over. So I didn't need a couple of these. So our next one is going to have a little bit of a new twist. As I go through this lesson, part of me wants to start skipping steps, but the bigger part of me says, just don't do it. Don't save time just to potentially make someone not understand this. So step 1, and if you want to try it this time, I know I just said this, I don't mean to be contrarian, but we can try doing 2 things at once. Nope, not a good idea. Let's go. Y equals, what do we do next? Move your 2. And let's go ahead and just leave well enough alone. We'll leave it like this, and we'll say 2, go move yourself over there. And part of the reason we want to move that physically is so that we don't accidentally include it in the next step. It cannot be included in this next step, okay? It honestly wouldn't hurt you too much in a case like this, but really we're better at math if we just pick away and just keep doing it that way. So next step. Pull out your GCF of only the first 2 terms. And you know what? Honestly, even if it's not a C, if it's not a GCF, even if these 2 terms don't have it in common, like I don't care. I'm going to pull out whatever number is where that arrow is pointing, to be clear. And I'm going to write you problems as is Delta Math that play nice. But if that were like a negative 4x squared plus a 9x, I would still divide. FYI, I would still divide by negative 4. Okay? We're not catering to commonality here. We're going to get out whatever makes x squared be a loner. So we're going to pull negative 4 out, and we're going to have y equals negative 4 times x squared. What goes after x squared? Well done on the sign change. Minus 2x. Good catch, everybody. Good job on the sign change. When you pull a negative, the sign in the middle changes. And that has a profound effect on the rest of the problem because it'll affect how we factor now. So now it's time to find the magic number. What's the magic completing the square number? Plus 1 is perfect. So I'm going to put a plus 1 here. See if you catch this one. You're a pretty savvy group. What number will erase the footprints of that plus 1? A plus 4. And again, the thing is, and you'll find yourself understanding this more and more as you practice, but the thing is, you have to embrace this purple connector. The purple connector will answer questions constantly about what should I do? What should I do? What should I do? What should I do? The answer to that purple distribution is negative 4, right? So all day long, I just ask myself, how do I get rid of whatever that is? And if it's a negative 4, I get rid of it by doing a plus 4. Okay, the rest is just factoring. So the work is done. Now you just have to tidy it up. So our answer is going to wind up being y equals negative 4 times what squared? X minus 1 plus 6. Done. Are you comfortable at this point? Okay. Last up are fractions, okay? And so let's get to it. I'm going to probably need a new page here. So let's do y equals 1/2 of x squared plus 3x plus 1/2. Being as robotic as I can be about this. So what is step one? Move your half. Kick that constant to the curb and clear yourself a workspace. So we have y equals 1/2 of x squared plus 3x, awkward space, plus 1/2. You're essentially putting that number in a timeout. And what are we going to pull out of the first two terms? A half. Very good. So we're going to have y equals 1/2 times x squared. What goes after the x squared? Plus 6x. So there's a thing in math about copy dot flop that you've known for years now. And the thing about factoring, when you quote unquote pull something out, you are dividing. You need to remember that when we pull something out, we're dividing. And so I'm going to show you a little bit of a math problem over here. We haven't had to talk about this yet because I've asked you stupid questions like what happens if you pull a 2 out of an 8? Duh. What happens if you pull a -3 out of a 6? Duh. Those are all duh questions. But remember, when we pull something out, we're dividing. So if I take the number on the inside 3 and I divide it by 1/2, then I realize, oh, snap. I'm not dividing it by 2. I'm dividing it by a half. And I wind up with 3 over 1 times 2 over 1, which is why there's a 6 right there and not a half of 3. So when you pull out a fraction, your middle number actually gets bigger because you're dividing by a fraction. And then I'm going to close these parentheses, copy down my timeout guy, and now we're back to algorithm mode. What number is going to go in the space? Plus 9 all day. Half of 6 is 3. 3 squared is 9, so I'm going to add 9. And how am I going to erase the footprints of that plus 9? What is the answer to this purple problem? This is really important because this is where you're going to get stuck. Not all of you, but when you do, if you do, this will be why. Look at the purple, and if you don't have it copied in your notes, copy it in your notes because that answer will guide you. What is the answer to the purple math problem? It's not 18. What is 1/2 times 9? 4.5. And I would prefer in this case that you not call it 4.5. I would prefer that you call it 9/2. Therefore, we're going to identify that red 9 is actually a 9 over 2. And to make it go away, we're going to subtract 9 over 2. If you call it 4.5, 4.5, it's not going to hurt you. It'll be just fine. Okay. So that's a little bit tricky. Pull a fraction, the numbers actually get bigger. And then now it's just time to tidy it up. So we're going to have y equals 1/2 times something squared. What is the something? X plus 3. And then at the back end, what is 1/2 minus 9/2? -4 is exactly right because it's -8/2, and 8/2, of course, equals 4. One more, and this one will be the culmination, sort of the hybrid of everything that you've learned in the last 20 minutes. It'll be all of our skills put together. So you could probably guess what's coming, but I'll just put it up here. I'm going to go ahead and save us a little bit of time and just move the 3 off to the side. So let's just copy it down. Because when you do these today on the computer, when you're copying them onto your paper, you'll be copying them down with this already moved. What's the sense in copying it down in its OG form when you know what you're going to do anyways? All right, let's begin. Step 1, pull out your factor, the number in front effectively. So we're going to have y equals, and we're going to drop or pull or divide out the -1/4, leaving this one, of course, to be x squared. Listen, if the one in front doesn't say x squared, you done messed up because that's the whole point, because we want that to say x squared. Aha, let's see if you've learned what's going to go after the x squared. Nope. Minus 8x. Because it is a positive 2 being divided by a negative 1/4. And a positive 2 being divided by a negative 1/4 is a positive 2 over 1 being multiplied by a negative 4 over 1. And that's negative 8. And that's what goes right there. Bam. And then I leave my space, copy down Mr. Timeout, and the algorithm continues. What's half of negative 8 and then squared? No. Yes, the number that we put here will always be a plus. Right? Half of negative 8 is negative 4, squared is positive 16. And then the sort of culmination of it all is what number will go right here to erase the footprints of that plus 16? It's actually a plus 4. And you would be within your rights to say, how did you get that? And I would draw your attention back yet again to this purple math problem. I have learned over the years that students that are willing to draw that purple bracket connector thing generally have a lot less issues with this than kids that aren't. And answer me this. What is the answer to that one purple connected multiplication problem? What is negative 1/4 right here times 16? That is negative 4 all day long. A negative times a positive is a negative, and a fourth times 16 is 4. And then all you have to do is say, well, what's the opposite of what I see? The opposite of negative 4 is plus 4. And it's over. And then you've got yourself a nice little pretty vertex form. So you have y equals negative 1/4 of something squared. What's the something? Yeah. And at the back? And that is done. Got it? That is how you convert a standard form quadratic into a vertex form quadratic. Your assignment is on Delta Math. This is not a do it in your head assignment, so I expect you to have paper. I know some of you are really into the whole whiteboard thing for whatever reason, but as long as you're showing work someplace else, again, these are not mental math problems. So let me know what I can do. I'll keep this alive so that within the next few minutes, inevitably someone's going to say, can you help me with this one? Or can we go over this one? And then I'll say, yeah, sure. And I'll snack it on the recording there. All right. Cool. What you got? Plus what? 15? 17. So we agree we're going to move to 17. Okay. And we don't have anything in front right here, which is nice. So these should be the less stressful kind of ones. So what you're going to do is you're going to complete the square right there. And what number is going to go right here? I need to know what goes right here. Say again? 25. Good. Thank you. And so what do we do to offset that plus 25? Right. So that is not one where we have to like mess with this number. It is what we think it is because there's no number that we pulled out in front. So then when you factor this down, you just get x plus 5 squared. And then you just have to do the math at the end. What's 17 minus 25? So that's it. Done. Oh, okay. This is a good thing. I forgot about this. My bad. Delta is going to ask you to name the vertex. So the vertex on a quadratic like this is at -5, -8. So you just have to name the vertex. It's as if we were going to graph it, but I forgot that it was going to have you do that. Good. Yep. Sorry about that. Steve, you okay, buddy?
Yeah, I just got the easiest question and now it's 6x squared minus 96x plus 318.
Nice. Would you like to do it together or are you up to the task? Okay, buddy. What do you have?
Let's go straight to the plus 5x.
Okay, so clearly I'm incapable of teaching high school math because I'm not capable of remembering all of the different types of problems. I was not aware that this was going to happen to you, so you're going to probably want to get your notes back out. Sorry for this. My bad. Some of them are odd. You really should stop whatever you're doing because I got about 3 minutes and I need them all because I did not know that any of these odd ones were in here. I should read more carefully. Apparently, the ones I clicky clicked, this didn't happen. I should have clicky clicked more. So here we go. So Alicia got this one. Lucky her. I guess all of you are eventually going to get these as well. So step one, I will amend my lesson for the other class because this is how I roll. They get generally a more comprehensive lesson as I learn from my mistakes. So what is different about this? 5 is odd, right? And so when we go to complete the square right here, then we have to consider that an odd number doesn't have something that's nice as a half of it. So what is half of 5? Yeah, and I hate to say it, but I'd really rather you just call it 5 over 2. But if you want it to be 2.5, then you can work this with a decimal. That's fine. So what we normally do is we take half of that middle term and we square it. And how do you guys square a fraction? What do you think?
5/2 times 5/2.
Yeah, you just square the top and square the bottom. So what's 5 squared? And what's 2 squared? Good. So we're going to complete the square by adding 25/4 right here, like this. Got it? I didn't know it was going to level up like this. So this is good. At least we can get this done. So how do we erase the footprints of that 25/4? If you're a decimal person, you have 6.25 right there, just for the record. So we just take away 25/4 or 6.25 if you love the decimals. People generally at high school like decimals more, a lot of students, just because our calculators can work with them better. And we love our calculators. And by we, I mean you guys. And so we're going to now factor. And this is a little bit tricky here because I've never asked you to factor something like this before. But you can do this. You know it's going to be X plus something. And I hope you're listening very carefully because the question is, how do you factor something? Don't pack yet. How do you factor something when there's a fraction involved? Well, it's really, really easy. You remember when we took half of 5? What's half of 5? That number that I'm circling in yellow, do you see it? Do you guys all see it? Do you see it? Do you see it? It goes right there. So whenever you take half, that's why you'll see me write that number down a lot because it's really helpful. And then at the end, you just got to do a little bit of grade school math. 4 is actually the same as 16/4. And then what's 16/4 minus 25/4? Negative 9/4. So, yeah, sorry about that. I'll give you some more work time tomorrow. I was unaware that you'd get those odd numbered ones. My bad. Probably re-record, I guess. I don't know. Maybe not. Have a good rest of the day.